All right, I'm going to continue working on the quiz review from page 66 in our books for Algebra 2. We stopped off at number 4? Yeah, number 4. So we're dealing with a bunch of transformations happening. Number 5 starts out with the function f of x equals 3 times the quantity x plus 2, and that entire quantity is squared. Now the transformation, the first transformation that we read about is, I'm actually going to deal with two things right now. They're translations. I have to go 1 unit left, and then I have to go 6 down. So I know then that I have an h value that is -1 to go with the negative k, or the 1 unit left, and I have a k value of -6 that I have to take the function 6 units down. G of x is going to be my new function, and what I'm going to do is, I've already got x plus 2 inside. I need to have that x plus 2, but I also need to take away -1. I have to take away -1, which makes it a +1 inside parentheses. I was already going left 2. I have to take it 1 more unit left. Put my square here. The moving it down 6 is going to happen by just putting -6 on the outside of parentheses. So actually, before I go into my next transformation, let me just simplify that x plus 2 plus 1 inside to x plus 3. That all squared -6. So it already had plus 2 to represent 2 units left. I had to take it 1 more unit left. Now the next part of the transformation for this has to do with, so this was just me simplifying from this line to this line. The next part of the transformation is asking me to do so I've got to go and take a vertical shrink of, where am I at here? Vertical shrink of a factor of 1/2. A is equal to 1/2. Now, what I know about vertical shrinks is that vertical shrinks affect, like, you multiply the entire function. So when a vertical shrink, when we read about it in our green packet and on our notes, a vertical shrink means you take the whole function and you multiply it. The entire function gets multiplied by the a value. And so I'm going to go and take, now my new g of x is going to become 1/2 of, and then I go drop this entire function inside, and I have to take 1/2 of all of it inside. Now the way this looks is, really, this group is going to wind up staying alone, because I think if you guys focus on what's happening here, you see that this quantity is squared and there's also a 3 distributed into it. How do I distribute a 1/2 across all of that? The way that you do that is just by multiplying it by this factor of 3 out front. And then that'll get multiplied by everything inside later on. But notice when I go to say about distributing this 1/2, I'm doing it just to, there 3 and then this -6 over here, because that 3 will impact everything inside. So my new function after that vertical stretch is going to be 1/2 of 3, which I'm just going to call it 3/2. 3 times 1/2 is 3 over 2. X plus 3 squared, I'm leaving that all by itself, and 1/2 of -6 is -3. So my function after I move left 1, down 6, and another vertical shrink applied winds up being 3/2 times the quantity x plus 3 squared minus 3. So you'll watch me do the same thing where I'm applying one after another. And I am doing a lot over here by just writing down what we're doing, but I was just hoping that that would help you guys understand how you have to go through it in stages. Now in number 6, the function we start off with is 2x plus 1 in parentheses, and that all squared, minus 11. Now the first thing that we have to do from here to here is a horizontal shrink. And a horizontal shrink, if I remember right, so they tell me that a is a 4th. But with horizontal shrinks, when I go over to my notes packet about horizontals, we go inside, we multiply the x only by the a, but I wanted to remind you guys too, we do the reciprocal of a. So if this horizontal shrink is a over 4, I'm going to take x and I need to multiply it by 4, because that's the reciprocal of 1/4, and I only multiply it by x. So what does that look like? 2 times 4, there's my x, plus 1 squared, all that, and my minus 11 is still staying the same. So inside, my g of x simplifies to 8x plus 1, all that squared minus 11. So my horizontal shrink showed up right here as a factor being multiplied by x. My horizontal shrink of 1/4 showed up in here as a factor, as x being multiplied by the reciprocal of the fourth. Now, after we do that, they want us to go and take and translate up 1 and 3 right. So if I'm doing up 1 and 3 right, up 1 means I've got a k of 1. 3 right means I have an h of positive 3. So, I thought it said up, didn't it? Translate, let me go back and look. Translate up 1 unit, 3 units right. So this 3 units right, so I'm back in g of x. I still have 8x plus 1. 3 units right means I have to go and take away a 3. X minus h, that's staying here. I have minus 11. K equals not 1. I need to add a 1. So I'm going through a couple things here. That's moving it right 3 more. And it's moving it up 1. So my g of x in this case winds up being, simplify what's in parentheses, 1 minus 3 is going to give me minus 2. And negative 11 plus 1 is going to put me at negative 10. So my horizontal shrink, was it a shrink? Yep. My horizontal shrink made this coefficient of x be 8. Moving it 3 units right. Changed my plus 1 to a minus 2. That would have implied left 1. So adding 3 units right would have taken it to a minus 2. I already had an implication that I was down 1, but I had to bring it up 1. So it worked out to be a negative 10. Now when we go into the next group of problems, 7, 8, and 9, there is a whole idea about graphing the function and labeling the vertex and axis of symmetry. So I had set up number 7, I've got my function sitting here. I need to find the vertex, I need to graph it, I need to label the axis of symmetry. I'm actually sitting in vertex form, and the fact that I'm in vertex form means that I can go grab the vertex, h and k, and so in this case then my h value is 1, and my k is negative 5, so this parabola has a vertex at 1 and negative 5. There's my vertex. I know it's going to open upwards. I actually need to label in the axis of symmetry. It's going to be right here. And then my strategy to get the rest of this graph, I've got the vertex, I have it labeled. Axis of symmetry is going to just be the vertical line x equals 1 that I put there. And then I'm actually looking around for my calculator so I can go find a couple more points on this graph. And I don't seem to have one handy. Here we go. So in my calculator, I'm just going to go put the function in to y equals and find another couple points that I could graph on this. No problem with using your calculator's table function, except the time it takes for your calculator to get warmed up. I am simply waiting. Has anybody put this in y equals yet? Still waiting on my calculator. Gosh, I could probably almost do it before. There we go. The vertex is at 1, negative 5. Oh my goodness, this is absolutely taking forever. Cool. So I finally got it. 2 times x. It's shutting off. Anybody? Points? 0 and negative 3. So 1 would go with negative 3 then, huh? Symmetric. Do you have anything over here? There's just a lot of space. Yeah, no, okay. Oh, you got a negative 1? Negative 1 goes with 3. That helps. And so that would go with 3 over there, just using the idea of symmetry. When you got a lot of white space on your paper, go grab another point. So vertex, axis of symmetry, and the graph of this one. Now I'm going to go ahead to, we still got the same requirements. Vertex on here, I know the x value of the vertex is going to be the negative b over 2a. Let's get some of this stuff. A would be 3, B would be 6, C would be negative 2. You know what? This is going to help me for graphing. Don't forget, you guys, C is the y-intercept. I'm actually going to put that point right on my graph. C is always where the parabola will hit the y-axis. That'll help us with graphing. I bet we don't have to go to our calculator for this one. The x value of the vertex is going to be negative 6 over 2 times 3. Negative b over 2a. So negative 6 over 6 is negative 1. The x value of the vertex is negative 1. I'm going to go plug that negative 1 back into the function. 3 times negative 1 squared plus 6 times negative 1 minus 2 is going to give me the y value of the vertex. That's going to be 3 minus 6, negative 3. I think it's going to be negative 5. Let me check here for a sec. I think the y value of the vertex is going to be sitting at negative 5. It sure is. So negative 1, negative 5 is the y value of the vertex, or negative 1, negative 5 is the vertex. The axis is symmetry, so they want vertex. They also want axis of symmetry, and that axis of symmetry is going to be x equals negative 1. And once I actually draw that axis of symmetry in, I can just use, I knew where the y-intercept was. I just did a mirror image of that y-intercept to get the shape of this parabola. I'm not surprised that it's kind of skinny, especially since the a value is 3. Not surprised it's a little bit skinny because the a value is 3. Now, moving on to number 9. Oh, number 9, yeah, this was a good question in here because I believe you guys need to see something like this. Don't forget that the a, b, and c values are fixed in terms of what numbers, or I'm sorry, what variables they're coefficients of. A is always the number stuck to x squared. So the a value in this case is going to be negative 1. A is always the number stuck to x squared, so the a value in this case is going to be negative 1. The b value is the number that's always stuck to x. This isn't working. So this isn't working. We're doing this right now. The b value is always the number stuck to x. And then the c value is always the number that's not stuck to anything, and it happens to be positive 7. So I had to actually go look at this a little bit differently. This is written as c plus bx plus ax squared. It's just rearranged. So standard form, again, my c value, let me go drop that on our graph. That's going to be the y-intercept, 1, 2, 3, 4, 5, 6, 7. So I know this point is on my graph. The x value of the vertex is going to be the opposite of b. b is already negative 8, so it's going to be positive 8 over 2 times the a value, 8 over negative 2. The x value of the vertex is going to be 4. I'm sorry, negative 4. That's also the equation for the axis of symmetry. So I know my parabola is going to go through this dashed line. That's x equals negative 4. I'm going to plug negative 4 into my function. 7 minus 8 times negative 4 minus 1 times negative 4 squared. And I'm going to need my calculator for that one. Let's see here. 7 times 8 minus negative 4. Or 7 minus. Make sure you're using the negative sign for that one and wrapping parentheses around it. I'm getting the vertex is sitting at, dang it, this is not a very pretty vertex at all. The vertex is at negative 4 and 23. Oy, oy, oy. I'm not even sure I want to graph this. There's my vertex. I don't even have my page set up to do a good graph of it. There's my axis of symmetry. Let's talk about this. How would this parabola open, up or down? It's based on the a value. Open down because the a value is negative 1. This is not a friendly graph for me to be having. The vertex is sitting at negative 4, positive 23. But I'm going to leave this one with just that sketch right there. I'm going to leave this one just with this sketch that it's open and down and where the vertex and what the rest of it is. Now, moving on to where are we at? Back in our book here, we've got to do numbers 10. Let's see. Grab me a new piece of lined paper. Problem 10. I'll get to your questions when we're done here, you guys. 10 is find the x-intercepts, then describe where the function is increasing and decreasing. So these are in intercept form, so it makes it easy to find the x-intercepts. Negative 3, and then I got x plus 4. Intercept form, tells us where the parabola is going to hit the x-axis. And intercept form is f of x equals a times x minus p times x minus q. And p and q are the x-intercepts. And then we also have to describe where the function's increasing and decreasing. And in order for us to do that, we need to find the x value of the vertex. And from what we learned last time, let's see, where am I at? In my notes here. There we go. Properties of, this is intercept form. The axis of symmetry, which is the x value of the vertex, comes from finding p plus q all over 2. So using that idea, the x-axis of symmetry, or the x value of the vertex, is -2 plus -4 all over 2. So that's going to be -6 over 2. The axis of symmetry is going to sit at x equals -3. Now, that's important because this is the value of x that's going to give us the information about what this parabola is doing. The parabola has a -3 for a, so it's opening down. So we talk about how this is increasing. You got it. Increasing to the left of -3, and it's decreasing after it hits -3. So to the right of -3. Increasing to the left of -3, decreasing to the right. They wanted x-intercepts and then increasing, decreasing information, and that was the work that I had to do to get to it. Same thing's going on in number 11. These are all in intercept form. Number 11's got me at g of x equals 1/2. This one's going to open up. 1/2 x minus 5, x plus 1. The p is going to be +5. The q is going to be -1. Those are my x-intercepts. Then I can take the x-intercepts and use the two x-intercepts in the equation. X equals p plus q all over 2. It's going to give me 4 over 2, or 2. X equals 2 is the axis of symmetry, which is also the x value of the vertex. We said this parabola is opening up if that axis of symmetry is sitting at x equals 2. That means that this function is decreasing to the left of 2. And it's going to be increasing to the right of 2. And then moving on to number 12, I'm going to put up 13 and 14. I'm actually going to stop this video right here because we're running out of time in 5th hour, and I will post the 12, 13, 14 video to my YouTube page after I do it in 7th.